Hello, everybody. Welcome to the TFA Tech Forum. Today, Xialin Liu from the ARM Trusted Firmware A team will present on the unification of chain of trust descriptors. Yeah, handing over to you, Xialin.
Okay, so I'm going to present the unified chain of trust tools today. And this is today's agenda. So I'm going to first do a quick recap of what chain of trust is, and then talk about the motivations of this tool. And then I'm going to talk about this tool in details, how to use them, and also a brief introduction to the implementations. And then I'm going to do the demo, and at last I'm going to talk about the future works, so the further iteration of the tools. So first, what is chain of trust? Before I introduce chain of trust, I need to explain what is trusted boot. And the trusted boot is basically security features that ensures the integrity of the boot process. It verifies each stage of the boot process. So to check if the image is authentic and unaltered, and then it helps prevent running unauthorized software firmware on the device, and the authentication is of the image is done by the chain of trust. And the chain of trust itself is a sequence of authentication image, which usually start with the root of trust, and they all culminates in a single data image. And for the motivation of these tools, currently the chain of trust have two options during the build process. So the chain of trust device tree file or its corresponding static C file for the platform that doesn't support the device tree file. And the two separate file is hard to maintain, and it probably introduce error. So unifying them would be beneficial. And also we cannot perform cross validations between the two options. So if there's future updates, we need to manually check if they diverge in the future. And they're basically duplicates. So duplication in software make the software hard to maintain in general. And also for the platform that doesn't accept the chain of trust device tree file, and there is no need to prepare a separate C file for it. So people can just use these tools to generate the corresponding C file and then integrate it into the build process. And here is the solutions. So the tool is called COT DT2C. So this tool will automatically generate a corresponding C file for the chain of trust device tree file. And it will also do an implicit checking to check if the file is valid or not. And currently it is already integrated into the build process on the ARM platform and convert the CCA, dual root, and TBBR chain of trust file into C file. And we also restructure the COT device tree. So we remove the BL1 chain of trust descriptor from the device tree and move it to a static C file. So as you can see the pictures, there's only one BL1 chain of trust C file under the drivers folder. We do this because the image that involved in the BL1 stage is pretty much fixed. So we find that it probably is suitable to just using a static file for it. But for the image involved in the BL2, it's varies, depends on the platforms. So we keep the BL2 chain of trust descriptor into the device tree file, and then it will be used to generate a static C file in the build folder, which the build folder is temporary folder during the build process, and it contains all the build image for the booting process. And the basic usage of these tools, so after installations, the tools can be used by typing cot dt2c, and then it have two commands. The first command is convert to C, so it do the conversions from the COT device tree to the C file. And the second one is the validate COT. So this one is basically do a validation of the device tree and to check if it is valid or not. And the basic structure. So for the first versions of this tools, it is done basically it is done by scratch. So we self-defined some of the data structure for each type of node in the chain of trust. So there are 4 types of node in the chain of trust: certificate image, trusted root public key, and non-volatile counters. And then each of them have a corresponding class on the right side. So for the generic, this can be used for both public key and non-volatile counters. And the script will recursively extract all those data structures and then fill in the attributes. It also do an implicit sanity check for the input COT device tree, and then they include a matching bracket, a matching if that macro, if they're missing root certificates, if they're missing mandatory attributes, if there are any malformed root of trust. For instance, a certificate that's having not parents, but it's also not a root certificate, or a certificate referring to a non-existing parent that we cannot find in the device tree. And the list can go on if we think of more test case to validate a device tree file. And also we can do an explicit sanity check by typing the validate COT command I mentioned in the previous slide. Okay, so here is the demo. The sound doesn't work, so we have to play this.
Yeah, hi Xialin. We can't hear you. Maybe you have to describe them, or you can play it maybe out of presentation. Yeah.
Also, so you cannot hear the sound for the.
No.
Okay.
No.
So for this is basically how like the tool is installed, and then for installation, just navigate to the directory and then type in make install, and it will install the tools, and then run a make test will basically test if the tool is working or not. It will do generations for a provided sample COT device tree file. And then here, if we type in the COT dt2c, and it will show up all the commands for this tool. And then to help, it's a help panel like to show the options of the tool and how to use it. And so like here, if we type in convert to C, and then it has two arguments, so the input file and the output file. So the input file should be the trusted chain of trust device tree file, and the output file should be the static C files. Yeah, so like here, it is the generated C files after running the command here. So for this command, you just need the input for the chain of trust device tree file. And so for this one, I run invalid brackets test for it, and then it throws the error as expected. So it will also indicate the errors. So for this test case, they are missing the mandatory attribute. For instance, the image ID is mandatory, and also the OID for the hash is mandatory. And also, like if a certificate is not root certificate, then a parent's attributes is also mandatory. So here it will output all um, the image names that's missing the mandatory attribute here. So here, they're missing the root certificates, and because these two are supposed to be the root certificate, but it doesn't have the parents, So so it will also throw error because they supposed to have parents, but they are missing the attributes here. And for these checks, so some the certificates referring to the invalid parent. So we cannot find the parents that they are referring to in the tree. So it will also throw errors and then indicate which image is referring to the wrong parent or invalid parent that doesn't exist in the entire tree. And to run make uninstall, and it will uninstall the tools, and the tools will not longer being inside, like being able to call. So okay. And for the future works, so for the next version of this tool, I'm going to integrate open source validator into the tools. And so it is able to get the attribute for the entire device tree. And there are two open source validators that we are considering integrated into the COT DT2C. The first one is DT schema, and the second one is PY device tree. And the DT schema is too restricted, so we found it will be harder to make it compatible with the chain of trust device tree file. So the second version is developed based on the PY device tree. And this version is pretty much done. And once we run some test case, we can push to the external to run a full set of test case on it. And for that, it is based on the open source validator and open source parser. So it's able to parse the entire things and then store it into the tree-like structures. So it will be easier to maintain the features, and also like it provides more features. So any questions?
How far did you go with validating the flow using the various configurations like test configs using 2 worlds, 4 worlds, context of ARM CCA? Did you actually run the whole CI test suite together with the tool, or how far is it integrated?
Oh, so I run the full TFA main on the tools, and then they all
Oh,
pass.
okay,
Yeah.
sounds good.
Yeah,
Okay.
so and I'm not sure about the second version because I just done it and it's not yet in the repo, but I run some local tests and they will pass. So like I suppose I'm hoping that I can push it like tomorrow or next week and to run the full test on it. But this version, the one I'm presenting, is already passing all like the TFA main test week.
Okay, I'm confident that it all works. It may be good though to align with fall from the RMM development, because the RMM component is not tested as part of the TFA CI.
Yeah.
It's tested as part of a dedicated RMM CI. So perhaps it will be good to confirm with RMM folks. Perhaps Arun can answer. I see he's in the meeting. To use this change as part of the RMM CI, perhaps.
Yes, that can be taken up. Yeah, as Oliver mentioned, as part of the TFA main CI, the RMM payload is it's a dummy payload, and there is no much RMA or RSA call is being exercised. So yeah, this can be taken up separately and in RMM CI and can be integrated.
Yeah, I think the risk is low because that's mainly about secure boot and the way to verify images. So
Yeah.
yeah.
Yeah, Oliver, I think that's what I mean. I think this is basically this change is basically affecting BL1 and BL2 part mainly. That is main players in doing the authentication of the images. So what Xialin has posted all the patches basically she invoked this tool inside the build system only. So if we build BL1 and BL2, this tool gets invoked for the ARM platform. So it is basically converting TBBR chain of trust file into the C file, even dual root chain of trust file into C, CCA chain of trust file into C. And I think, yeah, that is how it is integrated inside the build system. If someone want to create the C file explicitly, as she has shown, they can use the tool directly and even convert the files and use it in their build system. Yeah.
Yeah, thanks. I believe there is no risk neither to other integrations like shrink wrap. I guess as long as TFA is built normally, that there shouldn't be any change there.
Yeah, I also think so. Actually, means we are updating only the make file over there to invoke this tool.
Okay.
Yeah.
Perhaps I missed it from the presentation. How was the tool developed in terms of language? Is it Python or C?
Python.
Okay. So we expect the regular maintenance for tooling within TFA, like other tools that exist.
Yeah.
Okay.
And it is worth to mention actually the open source Python DT parser. She mentioned now she's trying to integrate that in her script. In that case, this tool can validate any device tree and showing what are the different problems in that device tree. So Xialin already tried, I think, what are the different device tree present in our TFA source code with that OpenDT parser. Correct me if I'm wrong, Xialin.
Oh yeah, yes, I already did. But I think it's still too restricted, so I'm maybe trying to figure out a way to make it less restricted and being able to parse more, files and validate more files. Currently, it's successfully recognized 16 files from the entire repositories.
So is this Python-based device tree parser is more exhaustive than DT schema?
So
or
no.
less restrictive than DT schema?
Yes, it is less restricted. The DT schema is so restricted that it only accepts like the file that starts with a backslash and a curly bracket, and also like for the register properties, it doesn't allow like using macros. It only allows using like numbers, like hexadecimals. So it's too restricted in the ways that doesn't really compatible with any of the existing device tree in the repository. So I also put notes on the Confluence page on what kind of things it doesn't take, and also it doesn't take any of the if that macro. So like if there's any if that macros, and they will reject the files as well.
Okay.
Yeah. So I have already put my finding on the Confluence page. So you can check like which kind of things that should be removed from the DTSI files to be able to run like the DT schema on it, because it's just way too restricted.
Yeah, that's good, because we need it. I mean, as you mentioned in your future work about making all the device tree in TFA at least compliant to the Python based one. I don't know how popular it is in industry. Is people using it?
I'm not sure about that also.
Okay, don't worry. We'll catch up afterwards.
Yeah.
Yeah. And one more thing to mention, we are running, I think, TFA main job, and it is working nicely, as she mentioned, but at the same time, some other partners also using this device tree chain of trust concept, like ST. So we are thinking we can check with them whether this tool is useful for them or not, and seeking some feedback from them, yeah, on this tool.
So any other questions? Yeah, so I think that is all my presentations. Okay, thank you for joining.
Thank you. Is there any question beyond presentation for firmware in general? It's an opportunity. Okay, if not, I will stop the recording.